Hey guys, welcome to another edition of Chemistry in the Classroom. And today we are going to talk about the periodic table and why it's important to you. So, one of the first things you need to know is that the periodic table has every single answer you'll ever need. The problem is that it's kind of hidden on the periodic table. So, one of the things we're going to talk about is how you, as a student, can use the periodic table to your advantage so that you get to have the correct answers just with you. So yeah, it organizes a ton of information. Now, here's the four terms I need you guys to have written down in your notes. The four terms are valence electrons, group, families, and period. A group is a column. A family is part of a group or a whole group or multiple groups, multiple columns. And a period is a row. Pretty much everything here, these definitions are all important to write down. So I would have those written down. I would also have these numbers across the top written in on your periodic table so you know which group is group number 1 and which group is group number 18. And then also have the numbers written for the periods 1 through 7. Those would be helpful things to do. Finally, if you haven't already, make sure that you have your valence electrons listed on your periodic table. So you know that group 1 has 1 valence electron and group 17 has 7 valence electrons. Okay, pause the video if you need more time, moving on. So before the periodic table came around, there was pretty much no organization whatsoever. So if you wanted to know more about an element, you had to look it up somewhere, like an encyclopedia or something like that. Then came Dmitri Mendeleev, and his goal was to kind of organize the periodic table a lot more. So here's what he did. He went ahead and he put elements in rows by increasing atomic weight. So that's protons and neutrons. And then he put elements in columns based on the way they reacted. Now, when he did this, when he did those two things, we hadn't discovered all the elements at this point in time. So there were blank spaces where he thought elements would be, and it turned out he was right. He also broke pattern of increasing atomic weight to keep similar reacting elements together. And that kind of goes to the number of protons. So if you look over here on the left, that's Mendeleev's periodic table. And you'll see there's a couple of different question marks that he has. Sometimes the question mark is, do we actually know what the atomic mass is? Sometimes the question mark is, we don't know what this element is, but we should have an element around here with an atomic mass of 180. And later we figured that out to be, I don't know, maybe thallium or hafnium, something like that. Looks like it's probably hafnium, which is kind of cool that they were able to discover that. If you see the atomic mass of 180 with titanium and zinchromium, right below it is hafnium. And so that was an element he predicted, for example. But yeah, so kind of cool how this is Mendeleev's organization. This is the organization of the current periodic table. The current periodic table is a lot more advanced. Then came along this guy named Moseley. You don't have to know these guys. This is just kind of background information. Moseley, this you do have to know, put everything in terms of atomic number. So Moseley pretty much discovered what a proton was, and that rearranged the periodic table to what we see now, where there's this periodic law, which is to say that you start with hydrogen, which has 1 proton, and then you move over to helium with 2, and then so on and so forth, all the way down and across, keep increasing the atomic number. It used to be based on atomic mass, but now it's based on atomic number. For the most part, they were the same, but there are a couple of things that got switched around. Like I think beryllium and iodine are switched around, or whatever's next to iodine. Is that beryllium? Let's see here. Yeah, beryllium and iodine. You'll see beryllium over here, if you can read that, has 126 as its atomic mass, and iodine has beryllium has 127, iodine is 126.9. So yeah. Anyways, periodic law is the term you need to know. Later, we put electrons in. We started figuring out what electrons were, and so we put groups based on electron configuration, which is why we can use the periodic table to help us figure out those electron configurations. Pretty cool. Okay, period versus a group. We showed you this already. Groups are vertical, these blue guys. Periods are horizontal, they are rows. Hopefully you have that down on your copy of the periodic table. Elements in the same group have similar chemical and physical properties. That's true. So if you look at everything in this first group right here, everything in the second group, like beryllium, magnesium, calcium, strontium, they'll all have the same number of valence electrons. They'll all have 2 valence electrons, which means they'll form the same kind of ions, which means then they'll, of course, react in very similar ways. So the important thing to know is same group means same number of valence electrons. That's a true fact. Okay, families are kind of like groups, but sometimes a little bit more, sometimes a little bit less. Families can be one column or they can be several columns put together. In the example of the transition metals family, families have names rather than numbers, in the same way that like your last name is a family name, it's not a family number. Yeah, okay. Here are the names of all the different families we'll ask you to know. Hydrogen is a family of 1. Alkali metals, alkaline earth metals, halogens, noble gases, transition metals, and metalloids. Metalloids technically aren't a family, but they're a small enough group that you want to write down where they are on the periodic table. So moving on here, what we're going to do is we're going to look to color our periodic table. And this is kind of what it should look like once it's all said and done. So here we go. First thing we have is hydrogen. So go ahead and in this little red box up here, color in hydrogen, please. Next thing we have is alkali metals. Alkali metals are in this blue box over here. Color in alkali metals. Alkaline earth metals are over in this box. Please color in alkaline earth metals. Here are halogens over here in column 17. Color them in. Here are noble gases over here in column 18. Please color them in. Here are transition metals. They are columns 3 through 12 right here in the middle. Go ahead and color them in. Over here now we have metalloids. These kind of follow a stair-shaped pattern, more or less. But the 7 that they are boron, silicon, germanium, arsenic, antimony, beryllium, and polonium. Those are the 7 metalloids. So please find a way to mark that on your periodic table. You might notice that there are some areas that are blank. There's this little area below the metalloids. There's this little area above the metalloids. And there's these 2 little rows. Here's what I'll tell you about them. You don't need to know them. Just know that everything on the bottom here is a metal. So we call them other metals. Everything above the stair-step line, above the metalloids, are non-metals. And then these 2 guys down below here are called the lanthanide and actinide series. They're also metals, and we won't really talk about them a whole lot. They're kind of weird, kind of bizarre. Okay, so this is what your periodic table should look like at the end of it all. If you haven't got a chance to color anything in, please pause the video now and make sure you color it in. Also, make sure that you're coloring very lightly because you still want to read all the information that's on the little periodic table cards, because that's important information that we'll use as we continue to move here throughout the year. There's the valence electrons. You should have those down as well. The last thing I wanted to talk about here is where the nonmetals are, where the metalloids are, and where the metals are. In general, the trend is if you're on the left side of the periodic table, that's where your metals are. If you're on the right side of the periodic table, that's where your nonmetals are. And if you're in the middle on this stair-step line, that's where your metalloids are. One notable exception of things that are on the left side that is a nonmetal is hydrogen. Hydrogen is a gas, so it really can't be a metal. Fun fact, we do have a liquid metal, a metal that's liquid at room temperature, and that's number 80, Hg, mercury, over there. Fun fact. There's a total of 89 metals, so most of the periodic table is made of metals. There's 20 nonmetals and 7 metalloids, which are kind of in the middle. So that's kind of a good takeaway message for the 118 elements we have on the periodic table. All right, well, I hope that was helpful for you guys. Take care. Have a great rest of your day. We'll see you later. Bye-bye.